4.6, we're going to be proving triangles congruent by angle, side angle, and angle, angle, side. So the first theorem that we have is using angle, angle, side congruence theorem, which says if two angles and a non-included side of one triangle are congruent to two angles and the non-included side of a second triangle, then they are congruent. Okay, and our postulate says for angle, side angle, congruence postulate, if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then they are congruent. So let's see an example here. It says, can the triangles be proven congruent with the information given in the diagram? If so, state the postulate or theorem. So here we have our markings, and we have an angle, and we have a side given, but recall we can add in the vertical angles. So now we have an angle and a side. So this is congruent. Angle, angle, side. Congruent by angle, angle, side. All right, next one, we have three angles. So this would be angle, angle, angle. Angle, angle, angle is not enough information to prove congruency. So we'll just put NEI, which is not enough information. Angle, angle, angle is not one of our methods for proving congruence. Okay, next one. We have angle. We can add the shared side. We saw that last class. We can add this shared side. So we end up having angle, side, angle. And we can say that those are congruent by angle, side, angle. Okay, let's see some examples of angle, side, angle proofs. So here's our two triangles. Recall that if we have two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then they are congruent. So let's see if our angle A is congruent to angle E and AB is congruent to DE and angle B is congruent to angle E, then our two triangles are congruent. All right, remember included means the side, the side between the angles. So let's see this first example. Given SQ bisects RQT and RST. So SQ bisects, so that's our given. Okay, so we're bisecting angles, so that means RQS and SQT are going to be congruent because of the definition of angle bisector. RQS and TQS. And we can also say that the other side is also bisected. So we've got these that are congruent as well. And this is also the definition of angle bisector. Okay, so now we can also show this is a shared side, so we can add that. It's congruent. QS congruent to QS because of the reflexive property. And then if you notice, we have angle, side, angle. So QRS, triangle QRS is congruent to QTS by angle, side, angle. Let's see another example. JK is parallel to LM. So let's put that marking in. JK is parallel to LM. JL is also parallel to KM. So we've got a parallelogram here. Let's mark those two arrows. Okay, so this is given. Oh, we've got our parallel lines cut by transversal again. So remember, our special relationships for those angles will hold true. So we have JKL is congruent to MLK. What kind of angles are those? Well, those are alternate interior angles. And it can go the other way as well. We can have JLK is congruent, oops, let me put 2 marks there, with MLK. MKL rather, right there. Those are also alternate interior angles. And then we've got KL congruent to LK. These are reflexive property. And then we can say that these two triangles are congruent because of, oh, we need to put this mark in here. Angle, side, angle. Let's just mark that in there so we see it. We have angle, side, angle. So that's an angle, side, angle proof. Okay, now let's see some angle, angle, side proofs. Recall that we have are 2 angles and a non-included angle. So this is angle, angle, side. So if angle A is congruent to angle D and angle B is congruent to angle E, and our side BC is congruent to EF, then the triangles are congruent. Okay, so let's see what proof means here, what our proof looks like. Okay, so first thing we have YZ bisects. So let's go ahead and write that. YZ bisects WYX, and angle YWZ is congruent to angle YXZ. These two are given. And we're going to mark our diagrams. Okay, YWZ is congruent to YXZ. Okay, so we have those 2 angles. Then we get this YZ bisects WYZ. So if that bisects, we're talking about that's our point of bisection. So we can write a definition of angle bisector. So this is angle WYZ is congruent to angle XYZ. So I'm going to mark my diagram showing that. That's from the definition of angle bisector. Then we can say YZ is congruent. YZ, that's a shared side. We can say that because of a reflexive property. Okay, and then now if you notice, we can say that these two triangles are congruent because of angle, angle, side. So let's look at this example. It says, can the triangles be proven congruent with the information in the diagram? So here we have angle, side, angle, angle, side, angle. So yes, this is an angle, side, angle. So that works. The next one, this is angle, angle, angle. That does not fit what's required, so this is not enough information. And lastly, we have angle, angle, side, angle, angle, side. This works for angle, angle, side. And that is the end.